Hello everyone. In this video, I'll talk about a machine learning algorithm which has wide applications and implementations in various fields of science and technology. The algorithm that I'll be delving into is the k-means clustering machine learning algorithm. As some of you rather may have heard about the k-means clustering ML algorithm, I'll delve into the whatabouts of k-means clustering algorithm in this video and how does it work. The steps in which the k-means clustering algorithm works. After that, I'll show how to implement the k-means clustering algorithm in a detailed way with the help of Python codes and popular machine learning library scikit-learn. So, before going into the whatabouts and working procedures of the k-means clustering ML algorithm, let me point out the examples of implementing the k-means clustering algorithms in this particular video. So, I'll show three examples of implementation of k-means clustering machine learning algorithm in the later part of the video in a detailed way. So, those are the simple k-means clustering with two-dimensional data. The second example will be k-means clustering on iris dataset. So basically, iris dataset is just to touch it, just to simplify. For the sake of simplification, the iris dataset is a classic dataset in machine learning algorithm that basically contains around 150 samples of iris flowers with 4 features: each sepal length, sepal width, petal length, and petal width. So it's a very common name in the machine learning field. Well, the third and final implementation will be the elbow method to find the optimal k, that is the number of clusters in a set of unlabeled data sets. Okay. So, to begin with, let me clarify the k-means clustering machine learning algorithm, what it is in actuality. Let's try to understand a little bit. So, it's a very popular ML algorithm that falls into the unsupervised classes. So, k-means clustering machine learning algorithm is a unsupervised machine learning algorithm that deals with unlabeled data. So, what does it do in actuality? So, to understand, we can define it like this. The k-means clustering algorithm is used to separate data or partition data into k distinct clusters based on similarity. So what does it mean in actuality is, what it means in actuality is, suppose we have few classes of data sets, suppose 20 data sets, 20 classes of data sets, those are mixed in an unlabeled manner. So what k-means clustering does is, it partitions the similar kind of data sets out of the unlabeled mixture of data or data sets. So the algorithm works basically by minimizing the variance with each cluster. If we differentiate the variance, it will be 0. But the way of minimization of the algorithm is done by the number of iterations constantly until we reach the actual cluster center, the exact cluster center or centroid more precisely. So this is the k-means clustering unsupervised machine learning algorithm in a nutshell. Now, if we try to understand how it works, how this k-means clustering machine learning algorithm works, then we have to understand 4 typical steps rather. Then we can understand very easily. So how k-means works? There are 4 rudimentary steps, which are the initialization step, the assignment step, the update step, and finally the iteration step. So how can we initialize this implementation of k-means clustering ML algorithm? So to get it initialized, we have to choose the number of clusters k. Now I've already explained what is the actual definition of k. I mean, what is actually what k designates, what k means in actuality more precisely. So if we want to implement the k-means clustering, or if we want it to work properly, we have to initialize first. And for initializing it, to initialize the k-means clustering algorithm, we have to choose the number of clusters k. So suppose we have 50 classes of data sets that are mixed in an unlabeled manner in a pot. Okay. Suppose there are data related to the heights of the human beings, or the ages of human beings, or men and women, and blah 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 blah. So it's like that. Okay. So each and every class is defined by, distinguished by a cluster. So what is the beauty is, they are defined as the clusters. That means the similar kind of data, or like data, or like classes, like class, basically like data in the same class, will be partitioned as a separate cluster. Okay, and the number of clusters is k. Now, so this is the first thing for initializing the k-means clustering algorithm, is to choose the number of clusters k. And now the second one is, we have to randomly select k data points as initial centers or cluster centers. Well, now what is the assignment step? In the next step, we have, for each data point, we have to calculate the distance, commonly Euclidean distances, that is pretty normal in mathematics. Suppose we have in coordinate geometry in three-dimensional space, we have 2 points in a 3D space, which are x1, y1, z1, and x2, y2, z2. and we can get the Euclidean distance between the two points from the abscissa and ordinates, and we can define it as the Euclidean distance as the square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 square. So that's the Euclidean distance formula. We know that it's a very pretty trivial one. Well, so for each data point in the assignment step, for each data point we have to calculate the distances commonly Euclidean to each centroid. So centroid means, suppose as we have defined earlier in the video, that suppose there are 50 classes of data sets which are mixed in an unlabeled manner in a pot. So each and every class, so all the data in a particular class is separated as a cluster, okay, is defined as a cluster actually more precisely. So the cluster center is called centroid here, okay. Now the idea is, in the assignment section of the working procedure of the K-means clustering algorithm is to assign the data point to the nearest centroid, that is the closest center, or more precisely the cluster center. And the actual motto, the actual goal or objective of this particular K-means clustering algorithm is to find the exact cluster center or centroid of a particular cluster, of all the clusters in fact, in an unlabeled data set, an unlabeled mixture of classes of data sets. So that's the assignment part. Now the update part, update section, we have to recompute the centers or cluster centers of the clusters by averaging the data points assigned to each cluster. That's quite normal, and then the centroid is now the new mean of the points in the cluster. Well, so the centroid means the cluster center, I've already explained. So our motto is to find the cluster center and the value of k. There is a number of clusters in a unlabeled a mixture of unlabeled data sets, right? Now the final step of the working procedure is the iteration step, where we have to repeat the assignment and update steps until the centroids or cluster centers no longer change significantly or a specified number of iterations is reached. So what it means in actuality is, suppose we are running the code, we are running the Python code with the help of the popular machine learning algorithm, as rather library scikit-learn. We are running the code. So and basically we are iterating and then reiterating until a certain number of reiterations. So or iterations rather. So suppose after 20 iterations, the cluster point or the cluster center, the abscissa and ordinate, or the coordinates of cluster point is something, okay. And if we reiterate for a few more iterations, then if there is no significant observation in the change of the coordinate or in the cluster center, then that is the final coordinate of the cluster center, and that is the centroid of the particular cluster, or that is the cluster center. So that is the actual goal, and then we can automatically also we'll find rather the value of k or cluster points, cluster number of clusters rather. Okay, so this is how the K-means clustering algorithm works. There are in 4 steps, okay, which are initialization, assignment, update, and iteration. Now, what are the objectives of the K-means clustering algorithm, right? So the basic goal is to minimize the WCSS. What is the WCSS? That is the within a cluster sum of squares, which is the sum of squared distances or Euclidean distances between each point and is assigned as the cluster centroid formally. Well, now the key parameters in this particular algorithm are actually k, that is the number of clusters, and the maximum iterations as well, where we have to find the cluster center or centroid, right? So that's the fact. And the maximum iteration is based maximum number of times the algorithm will run before stopping. Okay. Well, like many other algorithm, this k-means clustering algorithm has several advantages or amenities and disadvantages as well. So to talk about the advantages, it's very simple and first, and it works well when clusters are spherical and well separated. Okay, so well separated means suppose there are 25 classes of data which are that are mixed in a unlabeled manner. Now, well separated means all the data in a particular cluster or particular category, particular class more precisely, they are separated than other cluster or other classes or other types of data that fall in the another cluster. Okay, so they must be they are all separated. Okay, and in that particular case, this particular algorithm works very well. Now, to talk about the limitations of this particular algorithm is firstly the number of clusters k must be specified beforehand running the before running the code, before running the algorithm, and it's very much sensitive to initial centered also from centered positions, and those may converge to a local minima as well, where the second order derivative must be positive. Well, so also it may not work well with the non-spherical clusters or when clusters vary in size. Yeah. It also uses cases like image segmentation, customer segmentation, document categorization. So these things are all about this. Now k-means is often applied in conjunction with the elbow method to help determine the optimal number of clusters k by looking for the elbow point where the WCSS or within cluster sum of squares starts to level off. So in the later part of the video, I will implement the elbow method to find the optimal k with the help of Python codes and scikit-learn library. Well, so that's all about the whatabouts of k-means clustering algorithm. Then the steps of k-means algorithm, steps how the k-means algorithm works. There is objective, its limitation, its advantages, the key parameters, etc. And also it uses cases like image segmentation, customer segmentation, document categorization, like this. Okay, so this is the k-means algorithm. Now we will directly go to the implementation of k-means clustering machine learning, unsupervised machine learning algorithm, and also three examples of where I will implement the k-means clustering machine learning algorithms using Python and scikit-learn, the machine learning, the popular machine learning library. So the first example to begin with will be simple k-means clustering with two-dimensional data. The second example will be the k-means clustering on iris dataset. Basically, is a very popular dataset in machine learning section. And thirdly, it will be elbow method to find optimal k. Okay. So there I will show the step-by-step codes how to implement that k-means clustering algorithm in a detailed manner. I hope it will help you people to I hope it will help you people understand in a lucid manner how we can implement the very popular or very important algorithm, the k-means clustering algorithm, machine learning algorithm actually. Yeah, so let's start, writing the codes. Okay. So as you can see in the screen, I have already opened an interface of Jupyter Notebook. So I've opened it. Now I'll write the Python codes here for the implementation of k-means clustering machine learning algorithm. So the first example will be simple k-means clustering with two-dimensional data. So you can open the Jupyter Notebook by hitting Jupyter Notebook in the terminal, as I can show you here. I'm minimizing. So here I have written the Jupyter Notebook here in my terminal, and it has automatically led me to this type of interface. You can see this is the Python 3 IPy kernel, the kernel. I'm using Python 3 IPy kernel. So now I'll add the codes. I won't run the codes actually, but I will show how to implement the codes. Okay. Yep. So let's begin with the first example, that is simple k-means clustering with two-dimensional data. So let's write the codes for that. So this is our first example today, which is simple k-means actually. So this is the simple k-means clustering with two-dimensional data. Okay. Now to begin with, we have to import some necessary libraries like numpy, matplotlib, pyplots, and scikit-learn. So let's import some libraries. Okay. So let's import numpy. Then I'm going to import matplotlib.py plot pyplot. Then I'll implement the very popular machine learning library, that is scikit-learn. So from scikit-learn.cluster we will import the k-means. Okay, and I imported. Okay, that's the fact. Yeah. So I've imported all the libraries. So you have to hit shift plus enter after that to go to the next input line, and then you can write the next code rather there. That is we have to create a synthetic data there that will be implemented, in the algorithm. That will be used rather in the algorithm. So what I'm doing, I'm just gonna erase this data, this codes here, and then I'm gonna write the next code here. So, but you have to just understand this is the next code will be in continuation with this code, but I'm just erasing for my ease. Okay, but you have to understand that you have to keep in mind the next code I'm gonna write here will be in continuation with this particular code. Okay. Well, the next part is we have to create a synthetic data. So for that, let's write the code like this: np dot, because we're going to synthetic data, so a random number. $42, or it was 42. The next part is the data equals should be like this, equals np dot bstack. Okay. Well, so here we'll write like this. Okay, so it will be scale 100, 2. Okay. Then okay, so then well, so this should be, the size must be 102. Okay, so it's like that. Well, now the next one is np.random dot normal as well. So we log see equals, now this should be 510 in this case. So you see, you observe all things are same in these three lines, but the only thing is changing is the LOC things. Okay, yeah. Then as usual we have to write the scale. So the size is as usual, that is 100. So you see, in this particular, in these 3 lines that I have written here, in these 3 lines, all things are same except this LOC part. This thing, okay. In this case 2 2, in this case 8 8, in this case 5 10. Yeah. We are creating now. Now you have to hit the shift plus enter to create the synthetic data, as it will be created accordingly according to the code that I have written here. Okay. Well, now the next part is to apply the k-means clustering. Now the next you have to hit here shift plus enter in your keyboard, and then you will go to the next input line,
and thus in the then the synthetic data will be created, and then you have to go to the next input line
for the application of k-means clustering, and it's very, very important. Why? Because that is the main part. Well, so I'm going to erase this particular code, and then write the next code for application of k-means clustering, but you have to keep in mind that next code will be in continuation of this particular code as well. Okay, I'm just doing it for my ease. Yeah, so now the next part will be the application of k-means clustering. Okay, so it should be this is the thing that is very important thing. This over here we have to apply the k-means clustering part. Now let's try the code, which is like this. Now we imported this part. This is k-means earlier from scikit learn.cluster when we were importing the necessary libraries. So that is being used here. So this is k-means equals k-means. Now number of clusters will be 3. Just I am just using it as 3. You can use anything, and I am writing the code accordingly. So n underscore clusters, that is 3. Okay. Yeah. Now, so this is the k-means part. K-means equals k-means in number of clusters equals 3. Then we are going for the another thing, that is k-means that fit, and should be data. Okay. Then have to put the labels, and that is k-means dot cluster. Sorry, it should be labels. So I'm putting the labels here, so it will be labels. Then underscore. Well, so here what we have done, we have just putting the we are putting the labels on the as we know, this is the we are implementing our this unsupervised algorithm in case of unlabeled data. So we are just labeling the data or case or clusters actually. Okay. So that's what I have written the code for that here. So this is labels equals k-means dot labels. Okay. The next thing will be the cluster center, that is the centroids. Okay, the centroids here, that should be k-means Now this is, since this is a cluster centroid, so it should be a cluster here. Underscore centers. Well, so this is these are the centroid, the codes for centroid. This is like this: centroids equals k-means dot cluster underscore centers underscore. Okay. Well, now you have to hit the shift plus enter in your keyboard, and then you will go to the next code. There is the plotting of the clusters and the centroids, and where from you can get the cluster, centroids or cluster points, cluster centers rather. So for ease, I'm just gonna erase the data, the codes here that I've written, and then I'm gonna write the codes for plotting the clusters and centroids. But you have to keep in mind that next code will be in continuation with this particular code as well. Okay, so all codes are in continuation. So for my ease, I'm just gonna erasing this. I'm erasing this particular code that I've written here. Well, now let's plot the clusters and centroids. Okay, just plot the clusters and centroids. Okay, yeah, now I'll write the codes here. So for this, you have to do this plt dot scatter, and then the data points actually. Okay, so it should be like this. This is the thing, this is a plt dot scatter a data colon comma 0. Now it should be, so this is the thing, there is a plt dot scatter data colon 0 comma data one. So previously 0, now this is 1. Reverse then cmap equals VDDs. Okay, this is the thing. You got it? There should be a marker equal. So normal thing in the plotting that we do normally. Now alpha equals 0.6. Okay, yeah. Now the next code. So this is a plt.scatter. Now data we have put there. Now all the things are there. All the things like C maps, C map marker alphas are there. Alpha there. Now for the centroids. plt.scatter. This is for centroid. Okay. You know, 0. Now then this is the one thing to be there. Well, now the C marker is label. Okay. Now the marker equals X here. X, okay. Then S is 100, as I mentioned earlier also. Then I have to put some level. We have to put levels here. And the level is center, since we are dealing with centroids only in this particular code. In this particular line we are dealing with centroid, so we have to put the level as centroid. So let's just put it. Okay, centroids. So that's the part. Okay, just erase and let's write it again within the apostrophe. This one here. So this is the centroid. These are the centroids. Okay. Okay. Yeah. Well, now let's go to the next code. Now the title one. plt the title. So it should be k-means clustering, since we are implementing the k-means clustering. So let's just put the title as k-means clustering. Okay, so then let's put the plt dot x label. Now let's label the x and y axis. So this is x label. Feature 1, and then plt dot y label. sorry. Yeah, so this is the y level, the y axis. So as feature 2, let's put it. Okay. So I've already put the x level, y level. Now let's put the legend and so legend, and then we have to call the plot. So okay. So now the next part will be, let's put the legend also. Yeah, the legend. And then let's call the plot. Yes, so yeah, now this is the entire code. So I've already erased the previous codes, but you have to understand, if you keep in mind that those codes are in continuation, consecutive continuation. Okay, so the thing is that here you can see this is a plot section. This is a plot part where we are plotting the clusters and centroids here. So let's try to understand the codes a little bit. What I've written here, the steps. The final part is basically the plotting, and in case of plotting, you have to you can see the firstly we here the data points are here 0 1. There is a centroid, the cluster centers here. Then basically title. That is since this is a cluster, this is the case of K-means clustering machine learning algorithm. So this is the title I put here, K-means clustering. Then the x-axis, y-axis labels, that's feature 1, feature 2, and then we have put the legend, and then I'm calling the plot as pat.show within bracket. So then you have to hit the shift plus enter. You have to hit shift plus enter actually. Then you will automatically get the plot. Well, so this is the entire coding for a very simple implementation of K-means clustering algorithm using Python coding and the popular machine learning library scikit-learn. Okay, so this is a very simple K-means clustering with two-dimensional data, and you can see. Now let's talk about the steps in the code a little bit. So the firstly we have to we initialized we imported the necessary libraries. That's quite normal. Then we have created the synthetic data. Then we have applied the K-means clustering algorithm. Okay, we just use in number of clusters as 3. Then we plotted the clusters and centroids as this. So these are the main 3 steps of in the code, steps in the code actually. So in case of synthetic data, as I have shown earlier in the code, this is basically 3 clusters are generated with np.random.normal, and I wrote 3 np.random.normal. The LOCs were different. Then the K-means algorithm, K-means from sklearn, is used to feed the data and assign the labels to each data point. Okay, and the final one, that is the plotting, that this particular one, this is the one, this coding, this section. Okay, as you can see, this section is a plotting section, and in this particular section the clusters are plotted using different colors, and the cluster centroid or cluster centers are marked in red. Okay, yeah, so this is the first this is the implementation of K-means clustering machine learning algorithm with two-dimensional data. And the next one will be another example, the implementation of another example with the iris dataset, that is K-means clustering implementation on an iris dataset. So what is iris dataset? Iris dataset basically is a very popular classic dataset in a machine learning that contains 150 samples. I already explained it earlier, of 150 samples of iris flowers actually, with 4 features, each sepal length, sepal width, petal length and petal width. The goal is to group them into clusters. Well, so let's implement that also. So let's erase this data code rather, and then let's implement the another example of k-means clustering machine learning algorithm. Okay, this is one, and I am going to another. I hope the previous Python codes, or the way I have implemented the algorithm, the machine learning algorithm, the codes actually for implementation of k-means clustering algorithm will with two-dimensional data. I hope you were able to understand this. Okay. So let's write it. This is a k-means algorithm. The k-means clustering on the iris dataset. So this is the k-means clustering on the iris dataset. Okay. Now let's import some libraries as usual. Let's import some libraries. Some necessary libraries actually. Okay. So I'll be using the popular machine learning algorithm library rather, scikit-learn. Okay. So let's write it. Scikit-learn means sklearn. Sklearn means scikit-learn actually. Dot data sets. So we import load underscore now this iris data set we have to load it. Now from the sklearn dot cluster k-means. Okay. So this is importing We are importing matplotlib.pyplot as PRT. Oh, next part is now decomposition. So this is the from scikit-learn decomposition import PCA. Now, so this is now you hit shift plus enter in your keyboard. Then you will go to the next input line. So just do that, and after that we have to load the iris dataset. So for my ease, okay, let's write it down here. Okay, write it down. Let's load. Oh well, so let's load the iris dataset here. Now, the iris okay, so data equals iris.data, and before that prior to that is iris equals load underscore iris, within bracket. So now you hit shift plus enter in your keyboard, and then it will be loaded the data set. So then we will go to the next line of input, that is where we will be applying rather k-means clustering algorithm. So for my ease, I'm gonna erase this code rather, and then I'll write the next code. But you have to keep in mind the next code will be in continuation with this one, consecutive continuation. Okay. So for my ease, I'm just gonna erase this thing, and then the next part is a very important thing is that let's apply. So let's apply the k-means clustering. So let's apply k-means clustering here. Let's apply k-means clustering here. Now k-means equals, okay, the k-means that I imported in the from scikit-learn.cluster, I imported it in the when I was importing the necessary libraries. Well, so k-means equals k-means. Now here then our cluster will be also 3. Number of clusters equals 3. Okay, then the k-means sorry, so k-means dot fit underscore data. So this is the k-means dot fit underscore data. Then comes labels. K-means dot labels underscore. Okay, so this is the labels, k-means dot labels underscore. So the thing is that what we are doing is we are labeling we are doing the labeling kind of thing, actually, since this is unsupervised algorithm and the data are unlabeled. Now let's apply the k-means clustering. Now the next thing is that we have to apply the k-means clustering. Let's apply the k-means algorithm, k-means clustering actually. So this is the application of k-means clustering algorithm here. So for that we have to write k-means, the code that I've already written here. So the number of clusters is 3 actually. Clusters equals 3. So number of clusters equals 3. Then you have to fit it. Okay. So it should be fit. So k-means dot fit data. Now then so this is the k-means.fit data, then levels, equals well. So this is the application of k-means clustering algorithm. Here I am writing the codes here, you can see. So here you can see this particular case, k-means equals k-means number of clusters equals 3, and then we have to feed the data here, then the levels are leveling. Okay. Yeah.
So now the next part, so now you hit the shift plus enter, in the keyboard,
and it will be the k-means clustering algorithm will be all set.
Now you can, now I'll erase the codes written here just for my ease,
but you keep in mind the next code will be in continuation with this particular code. Okay. So the next thing is we have to use the PCA to reduce data to 2 dimensions for visualization. Okay. So let's use the PCA. Let's use PCA actually. And this is for visualization. Okay. Okay, so that's all.
now this is the code for this.
So since 2 dimension, we have to reduce to 2 dimensions. So let's write the code like this: PC equals so I imported PCA when I was importing the libraries. I imported PCA from scikit-learn.decomposition. So let's use this PCA here. We just want to reduce the data to 2 dimensions for visualization. Okay, since 2 dimensions, so let's put 2 here. Well, now the next thing is that the data this is in 2 dimensions. I have to reduce it to 2 dimensions. So the data here, so just put it 2D equals PCA pca.fit, I have to just transform the data. So let's use the keyword transform. So we have used the transform keyword here, since we have to reduce the data to the 2 dimensions. So this will be data underscore 2 dimension equals pca.fit underscore transform key. So the keyword transform here is used because we wanna reduce the data to 2 dimensions for visualization purpose. So now hit shift plus enter, and then it will be all set. So for my ease, I'm just gonna erase this data, erase this code rather, but you have to keep in mind that this code is in continuation with the next code as well. So the next code is the final one, that is the plotting. So there's the plotting one. So let's plot. Okay. So this is a plotting one. Let's write the code. Now it should be 2-dimensional data, since we have for visualization we have reduced it to 2 dimensions. So the next thing will be dimensional. So this is the k-means clustering on the iris dataset, and it's a plotting section. So plt.scatter, data 2-dimensional. Now there's 0 and 1 part. Now let's write. This is basically the C equals labels. So the idea is we have to understand that this is the from the plotting we wanna get all these the data or data points, and then from the plotting we'll get the cluster centers or centroids, and we'll reach our goal. That is the motto of this implementation of the algorithm of this machine learning, k-means clustering machine learning algorithms. Okay. So now see labels. then obviously it will come CMAP. So it will be CMAP, and the idea is CMAP equal, we know this will be the VDDs one, we all know. So this is the VDDs, okay, and then it comes marker equals O. Oh, it should be like this. So marker equals O, and then comes alpha. So this is the alpha part, and this is 0.6, okay. Now for centroid, not centroid, but this is the, for centroid or cluster centers, plt dot scatter k means dot cluster center, okay. So it will be like this. So this is the cluster center. Should be 1. So plt dot scatter k means dot cluster underscore centers equals sorry, so it's 0 here. The next part will be 1. So here it will be 1. Okay.
So this is k-means dot cluster underscore centers underscore this. Okay, then C equals marker sorry equals x. Okay, then the S is 100, level is centroid. Okay, as I'm doing it for centroid, this particular code, so now S so level equals centroids. Okay, okay, now then we have to just call the title, then it should be the k-means since this is a k-means algorithm, clustering algorithm, so let's put the title like this, k-means clustering. Oh, what's the double L? It's just to be removed. Clustering on iris dataset. Okay, okay. Now the next part is you have to just put the x label, y label and the result. So this is parity dot x label equals PCA feature 1. Since PCA, why PCA? Because it is converted to 2 dimensions for visualization. It is reduced to 2 dimensions actually for visualization. So the x label, it is PCA feature one. Then this is the x level, the x axis level. Now then the y level, let's put it as well. So this is the y level, let's put it like this. 2 then PL2 dot lessened and then so this is the lesson. So you have to understand why I have just written here the label as like the PCA or etc. like PCA feature 1 or feature 2 because this is the PCA data set. I mean the it is reduced to two dimensions. Okay, and that's why I've just written like that. So I've written the code for lesson as well. Then we have to call the plot plt.show. Okay, so plt.show. Well, so this is the code for plotting, and this is the k-means clustering on the iris dataset. Okay. So what is important here? So this is the all complete code for the k-means clustering on the iris dataset. So let's recapitulate the steps in this particular code, the step-by-step Python codes. Firstly, we have to import some necessary libraries such as scikit-learn, etc. We have to import PCA, we have to import k-means, we have to import load iris. There is a and then the second thing is that we have to load the data. That is the iris dataset is loaded using load underscore iris from sklearn or scikit-learn. The third thing is that we have to apply the k-means clustering algorithm. The data is clustered into 3 groups since there are 3 species in the dataset. And then fourth is the dimensionality reduction, that is by using PCA. So when we were importing some libraries or some things, we imported PCA as well. Now PCA is used to reduce the dimensionality from 4 features to 2 for visualization. Now as we know that I have already explained that in case of iris dataset there are 4 features. Now for visualization, for ease in visualization, PCA is used to reduce the dimensionality from 4 features to 2 here. Now finally is plotting. Now the reduced two-dimensional data is plotted with different colors representing different clusters. Okay, so here what you have to do is basically you have to hit shift plus enter and you will get the plot here. Okay, I'm not doing that. You have to do that. You'll do that. Okay, and you'll get the plot. Well, so this is that's all about the second example of implementation of k-means clustering machine learning algorithm, which is a very popular unsupervised machine learning algorithm. And the second one, that is this particular one, this one is done on the iris dataset. Okay. Well, now the final one that we have to, on the final example that I'm gonna implement the k-means clustering algorithm here is the elbow method to find optimal k. Now to find the optimal number of clusters, the elbow method can be used, which plots the within cluster sum of squares, the WCSS, for different k values. Okay. So WCSS, let's write the code for this without wasting time. So this is the elbow method. Let's write it here. Elbow method to find optimal k So let's write the code. So this is the WCSS, or within cluster sum of squares. Okay. So it's equals to this is the WCSS is basically within cluster sum of squares. Then for that's fine, absolutely. This is 111. Then K means equals K means. Now the number of clusters equals I here. Okay. So let's write it down. Equals I. So the number of clusters, n underscore clusters equals I. Then to just feed the data, so K means dot fit to the data then we have to do what? WCSS okay. So this is WCSS dot append came to inertia underscore. Now this is now where here the inertia is basically, let's write it down, is the WCSS for the given cluster. Is the WCSS or within cluster sum of squares sum of squares for the given cluster. Okay. For the given cluster. Okay, so the next, so you have to hit the shift, you have to hit shift plus enter. Then we'll go to the next code. So I'm gonna erase this code for ease in my writing codes, but you have to keep in mind actually, so the next code will be in continuation of this one. So I'm just erasing this code. So the next part is the final part, that is the plotting the elbow method. Basically, the plot will be like an elbow, and you will have to get the centroid or cluster points, or optimal k actually, and you have to get the optimal k. Well, so plotting the elbow method, yes. So here let's just plot PLT. Now the range is 1 to 11. So let's write it down. Then you mention the, oh sorry, this will be the 1 to 11. Then WCSS, let's write it down again. The range will be 1 to 11. The range will be 1 to 11. WCSS, the marker O, okay. Then PLT.title, and now the title, since this is elbow method, so I'll slide it down, elbow method. So this is elbow method, that's why I'm just putting this title as it is. Well, so this is the PLT.title, this is the title one, and then let's put the X level and Y level as well. So for that, PLT dot X level equals number of clusters So this is number of clusters actually. Well, this is the X level, that is the level on the X axis, so you have to just put T here. So this is the PLT.X level, that is number of clusters, and now let's put the Y level as well. PLT.Y level, so this is the PLT.Y level, that is WCSS. Then PLT.show. Just have to call this. We have to call plot. Okay, so Okay, so well, now hit shift plus enter and you will get the plot. I'm not doing it, but you will have to do this. You will get the shift plus plot. You shift plus enter. If you hit shift plus enter, you will get the plot, and the plot will be elbow like. So, what are the steps in the code to recapitulate? So this is the complete code for the elbow method to find optimal k. There is the number of clusters in the unlabeled data set. So the first step is the basically inertia, that is WCSS, inertia in WCSS within cluster, sum of clusters, sum of within cluster, sum of squares rather. And so here for each k value from 1 to 10, k means is run and the WCSS inertia is computed. The second and final step in the code is basically the plotting the elbow. That is, the WCSS is plotted against the number of clusters to identify the optimal k by looking for the elbow in the curve. Okay. Well, so I have explained, I have shown rather the implementations of 3 examples for k-means clustering machine learning algorithm, which is very popular unsupervised machine learning algorithm, and I have also explained the whatabouts of k-means clustering machine learning algorithms. I hope these examples have helped you understand the whatabouts of k-means clustering machine learning algorithm and its implementation in various fronts, in various sections of or realms of science and technology. Now these examples provide a foundation to understand and implement k-means clustering machine learning algorithms in Python using real or synthetic datasets. Okay, I have used both synthetic and real. Real means the iris one, the iris dataset, and synthetic means we have just created a dataset and then we applied the k-means clustering machine learning algorithm and then we got the results, the cluster center and other things as well. Yeah, the cluster center, that centroids. Well, so just to recapitulate what we have done throughout the video. So first I explained the whatabouts of k-means clustering unsupervised machine learning algorithm. I explained, I defined it, I showed 4 steps of working procedure for the k-means clustering machine learning algorithm, which are initialization, assignment, update and iteration. I explained the objective of main goal, motto of this particular k-means clustering machine learning algorithms. Then I also pointed some key parameters in the algorithm, that is k and maximum iterations, max iterations to be abbreviated or as abbreviations. I also pointed some advantages or amenities and as well as some limitations of this particular k-means clustering machine learning algorithms. Then I showed the coding, I showed the implementation of k-means clustering machine learning algorithms by giving 3 examples, by implementing it in 3 examples, by writing Python codes and with the help of popular machine learning library scikit-learn. And the 3 examples that I have implemented k-means clustering the 3 examples I have shown actually
for implementing k-means clustering machine learning algorithm using Python and scikit-learn, the popular machine learning algorithms are popular machine learning library rather. The examples are simple k-means clustering with two-dimensional data. The first one it was, and the second one it was. The second one was basically k-means clustering on iris dataset. Iris dataset basically is a classic dataset in machine learning that contains 150 samples of iris flares with 4 features each: sepal length, sepal width, petal length and petal width. But basically by using PCA, I reduced the dimensionality to 2 from 4 for ease in visualization. Well, now the final one is the elbow method to find the optimal K, that is the optimal number of clusters in the mixture or set of different classes of unlabeled data, that is unsupervised sets of data, that is unlabeled data. And finally, in the final example, I showed the implementation of elbow method to find optimal K, that is number of clusters, to get the optimal clusters, optimal K actually, number of clusters. So these examples actually provide a foundation to understand the k-means clustering algorithm and as well as to implement so. Well, I hope you people have understood the whatabouts of k-means clustering algorithm actually, to be precise, and its implementation with the help of Python codes and popular machine learning library scikit-learn. You may follow the code thoroughly to understand the implementation of k-means clustering machine learning algorithm, which is a very popular unsupervised machine learning algorithm in the fields of science and technology. I hope it helped you a lot. So it's all in this video. Let's meet in the next video. Good luck.